This is question number 3 from the 2001 AP Calculus AB exam. Okay, so we're given this piecewise function here, and we're told that a car is traveling on a straight road with a velocity of 55 feet per second, and for 0 to 18 seconds, we've got the car's acceleration in feet per second squared. So up here we're looking at the car's acceleration. So for part A, we want to know, is the velocity increasing at t equals 2 seconds? Well, here's t equals 2 seconds, and it looks like the acceleration is positive. So since a of 2 is positive, and the acceleration is the derivative of velocity. If the derivative is positive, then the function must be increasing. So since a of 2 is greater than 0, velocity must be increasing at t equals 2. Okay, part B. At what time, other than t equals 0, is the velocity of the car 55 feet per second, and why? Well, let's take a look. Here we're starting at 55 feet per second. Acceleration is positive, which means that our velocity must be increasing. So velocity is increasing, but then velocity starts decreasing over here. And note the symmetrical thing that's happening here, that this area is equal to this area. So I would say that the car is going at 55 feet per second at t equals 12 seconds because our velocity function has decreased back down to its starting point. Now there are a few different ways to justify your answer. You can write out in words something along the lines of what I just said. I kind of like to make things simple and say that this is happening at t equals 12 seconds. And it's because if we took the integral from 0 to 12, we would get 0, meaning that there's 0 change in the velocity. Okay, part C. So now we're talking about absolute max velocity. So we want to know when the function has a maximum. That's going to happen either at the endpoints or at a local max. So where would we have a local max? Let's see here, endpoints. A local max will happen when the derivative changes from positive to negative. And that is happening right here at t equals 6. That's not happening at t equals 16 because our derivative changes from negative to positive, giving our function a local minimum, which is not what we're looking for today. So we've got to decide if the absolute max is happening at the endpoint or at t equals 6. So what do we know? We know that v of 0 is equal to 55. That was given to us in the directions. So let's try to find v of 6. Now we know that the starting point is 55, but then our velocity increases. All right, we see this here because acceleration is positive. And we can find out how much by finding this area. So we're going to calculate the area from 0 to 6. So that's 55 plus, let's see, we've got a trapezoid, a base of 6, a base of 2, and a height of 15. So let's see, 1/2, a base of 6, a base of 2, and a height of 15. So that turns out to be 55 plus, this is 8, half of 8 is 4, 4 times 15 is 60, which is 115. So 115 is definitely larger than 55, so we know that v of 0, this here is out. That can't be our absolute maximum. Now we know that the velocity over here at t equals 6 is 115 feet per second. But then the velocity is going to decrease, 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 and then increase just a little bit. So the velocity is spending more time decreasing than it is increasing. So that would mean that the integral between 6 and 18 would have to be negative. We can see that also because more area is below the x-axis. So if the area from 6 to 18, or I shouldn't say the area, if the integral from 6 to 18 is a negative number, that means that the velocity at t equals 18 must be less than the velocity at v equals 6, which we know, or v of 6, which we know is equal to 115. So therefore, the absolute maximum velocity is 115 feet per second, and this occurs at t equals 6 seconds. Okay, now we're on to part D. So part D, at what times, if any, is the car's velocity equal to 0? Okay, so that's an interesting question here. Let's see what happens. Our car, we know, starts at 55 feet per second, increases to 115 feet per second, decreases back down to 55 feet per second, but then continues to decrease. So, how much more does that decrease? Let's find the area right in here. We've got another trapezoid, so it's 1/2 of the sum of the bases, so this would be 4 plus 2, 4 plus 2, times the height, which is 15. So it's 3 times 15, which is 45. So that means that the velocity at t equals 16 is 55 minus 45, which is 10 feet per second. Now this is the absolute minimum. The absolute minimum, which means that the car's velocity is never equal to 0.